All right. So today we're going to do 1 through 4 from the worksheet today, one step at a time. I also recommend make sure to watch the Khan Academy video first. If you're watching this first, make the Khan Academy videos that's on the assignment first. The reason is it'll visualize what's happening. So let's do number 1. Number 1 is very nice because it's bounded by the x-axis. So because it's bounded by the x-axis, we don't going to have any problems with solving it. So the first equation is y equals x squared plus 1. And then it's bounded by y equals 0, which is the x-axis, which is really nice. So when we say bounded, last section, when we said we're making the volume, we'll say it's from a square or it's from an equilateral triangle. And that's like projecting out of it. For this one, we're going to say it's rotating around the x-axis. So if you have your like x and y axis like this, we're rotating around the x-axis. So to visualize a little better, you're like rotating it around the x-axis like this. And what that causes, like each, and if we do the rectangles, just like we did before when we first learned integrals, each rectangle would be rotated around the x-axis, kind of like this. And it will make a single coin or disc shape. And that's why it's called the disc method. So there's a little disc, and then you make another little disc, and another little disc, and another little disc, all the way up and down. And what that causes is this full figure. So then we have to, and the smaller the disc, the more accurate it is. So we want to use an integral, which is the sum of the limits of infinitely small rectangles, or in this case, discs, because they're 3D. Now let's just think about it. A disc or a coin is a very small cylinder, like a cylinder with a small height. Now first let's talk about what the actual height is of the cylinder. It's going to be where the beginning of the bound is and the end of the bound is. So the beginning of the bound and the end of the bound for number 1, it's going to be where it hits the x-axis in this case. Now you could just do 0 equals negative 2 x squared plus 1, or you could just look at the graph. In this case, it's negative 1 and 1. So our integral is going to start off with negative 1 and positive 1. So our integral is bounded by negative 1 and positive 1. Now, the height is from negative 1 to positive 1. How wide is it? So that's going to be the base. Now, the base is a cylinder, right? It's a bunch of little cylinders. So the base formula for a cylinder is the base of the volume, so or the base of the circle. So it's the area of the circle, which is pi r squared times the height. No, times the height. So that's the area of a cylinder. The height we already took care of right here with the bounding. So this thing right here, the radius squared, we have to take care of. The radius changes depending where you are. If you're at 0 on that graph, it's the widest as possible. If you're at a half, it's a little closer. A fourth, it's a little closer, or a little wider actually. So we need to show that it's changing from how far you're going in or out of the line of the x-axis. So in order to do that, what we're going to do is rewrite the equation, but our r is going to become our formula, or our f of x, or I think we use a of x sometimes when we're talking about area. So pi is still there, so I'm going to write pi. I'm going to red because that's always there. So pi is going to be right there. Then we have radius squared. That radius changes depending where you are. So we're going to put the whole equation negative x squared plus 1. This whole thing is squared. Now the h is the change, or the infinitely small rectangles. So that's just simply of dx. So that is simply dx. So this is how you want to set up your integral. It might be easier, and then from there we could plug it into our calculator. Now, this is a constant, the pi, so you could move it in front. And then I'm just being cheap and rewriting like this. But after you set it up like this, then you could just plug it into your calculator. So we have pi is the integral from -1 to 1, negative x squared plus 1, all of that squared. Make sure the whole thing's squared. You could technically do this by hand, by foiling it or doing u substitution, but again, we have that calculator. And all I'm going to do is just check the answer sheet, see if it agrees with me, which it does. And the answer seems to be 3.351 after you plug in your calculator. If you does fractions automatically, 16 over 15 pi. If we were doing it by hand, it would look like 16 over 15 pi. Again, we tested on doing it by hand, so we don't have to worry about that. Most important part is the setup. Mathematically, this is not too hard, but it's all the visual and like understanding what's happening. Okay, so we're going to look at number 2. Do you have a question, Max?
Yeah, you're saying it is possible to do it by hand, it just takes longer, right? Is that you're just...
Yeah, you would do either, you could do u substitution in this one, or you could foil it out and then just do each one individually.
Well, I mean, I can also do this on my calculator and then do the antiderivative by myself, right?
You could check your work with one or the other, right? You could do the antiderivative, then check your work with the calculator, or vice versa. That's fine. Okay. So we're going to go to let me show the screen at least, or the class here. So we're going to go to the second one. Now this one, what happens in this one is that it's not connected to the x-axis, so it's not a solid cylinder. What happens is there's this hole in between the cylinder. So this one, it's like that. So let's say that's the first circle, right? But there's this like, and then here's the other circle. Again, I would recommend watching the Khan Academy because it's much more accurate. I can't really draw this well. Basically, you're going to have a circle or a cylinder, and then inside here, there's going to be this inside part of the hole. And the hole of the cylinder changes along the way. So what we actually are finding, let's say if it was like an area formula, like geometry, you would find the area of the big circle and subtract the area of the small circle. The same concept applies. We're going to find the area of the larger cylinder and subtract it from the area of the smaller cylinder. So we're going to go back to the whiteboard. So for this one, we have our two equations. Y equals 2x plus 2, and y equals x squared plus 2. Okay, so you have your top and bottom. So you have to first decide which one's the top, because the one on top will be that bigger because it's going farther away on the rotation. And it seems like the top one should be 2x plus 2. So this is the top one and this is the bottom. Okay. So before we even start, we need to know how high our cylinder is or how long it is, technically, if you're looking at it like that. So we're going to look at the intersections. Again, you can set these equations equal to each other, or we could just look at the graph, which seems to be at 0 and at 2. And let me just check. I think it says around the x-axis. Yeah. So 0 and 2. Okay. So we have 0 and 2. So first we want the formula for the top part. So that's going to be pi. And remember, it's still a cylinder, so the same formula applies as pi r squared times height, but the height is taking care of the integral. So pi times this right here, which is 2x plus 2, close parenthesis, squared. So this is the top part. So this is the bigger circle. And we're subtracting the area of the volume of the smaller one. So that's pi. And now we're going to take the one that's a smaller cylinder and it's closer to the x-axis. That's why it's smaller. Its radius is effectively smaller. X squared plus 2 squared. And all of this is dx. I'll just leave it there. Okay, so we have our formulas here. What's really nice though is that these are both multiplied by pi. So I could move my pi to the outside of my integral. So pi goes here. And then I have my equation here. Again, you could do this by hand and do the antiderivative. I always recommend doing the calculator though. This is the setup for the equation. I'm just trying to check the answer if I'm correct. Now they even took out the pi also. Seems like I'm correct. That's how you set it up. Then the solving or the equation's up to you guys, okay? So that's 1 and 2. Before I move on to 3 and 4, does anyone have questions on 1 or 2? Okay. So we're going to the next one. So the next one is we're not rotating around the x-axis anymore, which makes our radius a little different. So first, let's draw the equations. I'm going to clear all this. So let's draw the equations. So for number 3, it's y equals root x plus 1, and y equals x squared plus 1. Okay, so first let's just identify which one's the top one. The x squared is the top one, and this one's the bottom one. And why don't we just start off by also finding where they intersect, which seems to be at 0 and at 1. Okay, so look at the easy stuff out. Now is the setup part. These are still cylinders because they're getting rotated around the x-axis. These are still cylinders, so we're still using the same equation, pi r squared, where r is our formula or function. But now it's at x or y equals -1. So what happens there is that since the distance have increased by 1, so you went down 1, right? Like it's going like the radius from the x-axis, let's say at 0 is 1, but now it's at 2. The radius at 1 is at 3. So you're effectively adding 1 to both the top and the bottom. And I'm just going to look it up because I don't want to mess up the negatives. I just want to make sure I do the negatives correctly. But effectively, all you're doing is because it's y minus 1, you're either adding or subtracting from the function. I'm trying to find it here. Either adding or subtracting the function. So from 0 to 1, we take out the pi. And we are going to subtract the new axis. So what's going to happen is that we're going to put, now the radius is slightly different now. There's still pi over here. The radius is slightly different because the first one is the top, so that's square root x plus 1. That still stays the same. And then we're going to subtract our where we're rotating, which is at -1. So this yellow one is because the axis is at y equals -1. Then let's go to the next one. So that's subtracting. Now we're going to subtract the smaller one. pi, parentheses. We're going to do now the bottom function, which is x squared plus 1. And I'm sorry, you're supposed to it's minus the y-axis, right? So it's minus your new line, but it's a negative, so I want to make that clear. I'm minusing -1. And over here, I'm minusing -1. If it was y plus 1, you would do add or minus normal 1. Sorry, I didn't make that clear. And then close the parenthesis with a little dx at the end. So effectively, if all you do is differently when it's not the x-axis, is that you're going to subtract whatever your new line is. So if it was at -10, you do minus -10. If it was at 4, it'll be -4. So wherever your y-axis is. Okay. So that is our function here. And we could combine some like terms. So we could make this square root of x plus 2, because it's double negative, minus, oh, and don't forget the little squares. My fault on that. So it's squared, minus x squared plus 2, close, squared, dx, integral from 0, 1, and then we have that pi on the outside. And I'm checking the answer. Seems we have the right setup. Again, all of this is calculator or by hand. I recommend calculator. All right. So that was number 3. I was a little flustered there. I messed up a little bit of my explanation, but if anyone has any questions, I'm happy to take it. I do have to apologize, so I messed up a little bit. Okay. Let's start the next one. Oh, Max, you got a question?
No, Michael.
Oh, Michael.
Oh. Can you explain where you got the negative, like the minus -1, the yellow?
Okay, so are you looking at the worksheet right now?
Yeah.
Okay, so the problem is asking, find a solid rotating around this different axis, not the x-axis. So they gave us y equals -1, so we have to rotate it by y equals -1. So whenever the new rotation is, it's just going to be minus whatever it is. So if it was like y -5, y equals -5, you would do minus -5. It was y equals 6, it'd be -6. So it's whatever the new axis they give you.
Okay.
Okay.
Thank you.
All right. Am I good to clear this? Everyone okay? Anyone not okay, actually? All right. So let's go to the next one. Number 4, I believe I only asked you to go up to 4, right? Yeah. Okay. So this one's different. They're asking us to rotate it around the y-axis. So we're rotating around the y-axis. And particularly a y-axis of x equals -2. So there's like multiple things going on. Now, if, like, what I would probably give you as the equation is that probably would have wrote like, let's make one up, like y equals x plus 1. If you're rotating around the y-axis, you need to make your equation solve for x. So you would have to subtract 1, subtract 1. So you will have to change your equation into y minus 1 equals x. Because now we're talking about like the inverted, not inverted, that's the wrong word. We're looking at the y-axis compared to the y-axis. So here, though, in this worksheet, they already gave it to you in terms of x. So that makes it a lot easier. But just make sure, if you're solving for the y-axis, or you're solving for like a vertical version, it has to be equal to x. When you're solving for the horizontal cylinders, it should be equal to y. Because think of it as your circles are being drawn through the y-axis, and this is being drawn to the x-axis. Okay, so let's get this. So first one is, maybe it's easier to type. X equals negative y. No, exponents. Squared plus 2. And your second equation is x equals y. And we have our new axis, and our new axis is x equals negative 2. Negative 2 right there. So we're going to have to do it. First, let's identify what's on top and bottom. So which one of these two are closer to the y-axis? The one that's closer is going to have a smaller radius, which is going to have be the smaller cylinder. So we're going to subtract it out of it. And it turns out from this one, even though if we were doing the x-axis, y equals x would be the bigger one, this one in this case, it's x equals y is the bottom. So this is the bottom one. And then this one's the top one. The closer you are to the axis, or whatever you're rotating around, is going to make you the smaller version. Okay, so now we're going to find the intercepts. But remember, since we're rotating around a y-axis, we're going to have to use the y-intercepts. So the y-intercepts in this case is negative 2 and 1. It only happened to be that the x and y's are the same intercepts. That doesn't always happen. But we're looking at the y value. So it's at negative 2 and it's at 1. Okay, let's take our bigger circle. So let's take our bigger circle. So the pi, that's never leaves us in this case. And we have our bigger circle, which is going, or the bigger cylinder, which is negative y squared plus 2. But we have a new axis, which is at negative 2. So we're going to subtract negative 2. Then from there, we close the parentheses and square it. And you could rewrite that as plus 4. That's going to be subtracted by the smaller version, which is much easier. It's just y. But we can't forget that minus negative 2. All that squared, and then we have a dx. I'm going to type it out to make it a little shorter. So we have pi, pi from the integral. There's no way to type this. So it's pi, the integral of, from the integral of negative 2 to 1, close parenthesis, negative y squared plus 2, plus 4, because double negative becomes a positive, squared minus, and I took out the pi, because they're both being multiplied by pi, I only have to take out one pi. I'm factoring out. Y plus 2 squared dx. Oh, I'm sorry. This is all y, so it's dy. My fault. That should be dy's. One more check on the answer before we're done. It seems like we're all good. If you plug into your calculator or do your antiderivatives, you should get your answer. Right, I think that's all 4 questions of the homework. Very nice.
Thank you.
So I'm gonna give you 4 questions. Do you guys have any questions for me in general? If not, you're free to go. You're always free to go, but now you're even more free to go. Have a wonderful day.
Have a great day.
Uh,